Jack Howard, and I did my capstone on supply chains and the collaboration of firms inside of supply chain. And inside of supply chain, there are two different types. There are firms that just work with one supplier or multiple suppliers themselves and order their inventory and things of that nature. And then there's also another form of supply chain is when they have a third-party supply chain manager, is when there is a third party that manages all the inventory that says, okay, you are sending X amount of goods to this firm every day, and they handle all of the logistics for these larger firms. And most of the time, that's like manufacturing firms that do not have the figured out that the specialization of somebody handling their supplies for their sites, manufacturing sites, is more efficient than them handling the logistics themselves. And there's also partnerships where they have logistic departments within themselves and an outside logistics department consulting for them. And the largest problem that supply chains run into is called the bullwhip effect. And the bullwhip effect is happening is that if we go to the first diagram, you can see it pretty well. I might just zoom in for you guys. Is that information about the about the amount of supply in a supply chain starts at the beginning of the first supplier, and I used a very basic model of a lumber supply chain, and it starts with the logging company, the company that actually logs logs out of forest, and then ends with like retailers like Home Depot or Par Lumber selling the actual goods. And I just chose one good as a 2x4, kind of keep it very simple, keep the variables down. And the supply information originates with the logging company. The amount of logs in the system affects the amount of 2x4s in the system, and and as they say, the information flows downstream from the logging company to the retailers. However, the demand information starts with the retailers and flows upstream to the logging company. And the delay between the supply information and the demand information causes these variances in inventory and forecasting that becomes, huge problems for retailers down here about information about their supply, and logging companies when they're trying to make forecasting about how many logs they're supposed to harvest per year. And the reason why they call it a bullwhip is that it exponentially grows the further you move from the origin. So the supply information, the variance, the time delay affects the retailers the most, and then the demand information delay affects the logging companies the most. And the three things that affect the bullwhip effect is collaboration, lack of information, and just the physical structure of the supply chain. How many, boats and ships and stuff that practically how many goods you can ship at once. And so the two parts that I looked at was lack of collaboration and lack of information. Is that if these firms work together, then they can decrease the lack of information and increase collaboration. And as I went through my study, I found is that the most effective solutions come from the supply side variance. Is that there's so many different factors about the demand and predicting the market, and recessions, and you're having to make all of these predictions that just make it almost nearly impossible to decrease the variance on the demand side effectively. However, you can decrease the variance on the supply side very effectively by partnering with the firms that your suppliers. And going back to the model, we see is that there is a variation of games here. Is that the logging company's most important supply relationship is the mill, and the mill's the same same thing, is that they're passing supply information back to the logging company, and the logging company is passing them trees, and that there's a series of these relationships across the entire chain, but one relationship between the logging company and the mill does not differ greatly between the supply relationship between the mill and the distributor. And so I created, modeled these games where, practically speaking, the mill would start off with multiple suppliers, and there would be 3 suppliers, and they would have varying stages of collaboration. And when I was doing my research, looking at supply chain textbooks and talking to some supply chain professors, they were saying is that as their time horizon goes on, they'll increase collaboration, or they will stop becoming their supplier, because if logging company A signals to the mill that they're willing to collaborate and bridge the gap of asymmetrical information, then they will reward that information by signing larger and larger contracts, which would end with what they call marriage, is that there's a sole suppliership of logs from one logging company to one mill. Or it wouldn't be a monopoly per se. They might be filling orders with other logging companies, but practically speaking, the majority of their supply is coming from one firm, or a handful of key firms. And the next model I showed is that it's kind of where there's one logging company providing the mill with all its suppliership, and a wholesaler is kind of trying to drive at the same effect, where they're wanting one mill providing the bulk of their supply, because if the more suppliers they have, the more variation they have, and the bullwhip effect is dramatically increased. So you have 3 variables exponentially increasing instead of just one. And so, there was, I modeled my game. I created a literal game of game theory, where the mill is making their decision is either increasing the contract size or keeping it current, and then the logging company is either keeping the same fulfillment by the inventory variance, or they're increasing their fulfillment to the mill by signaling of some sort. And the practical study I was doing was what type of signals are effective, and the 2 signals that I looked at were marginal cost and inventory. I was actually talking there when Tanner was reviewing my paper. That was one of the 2 things, is I had a list of variables that I was trying to look at, and it wasn't practically to find that information. I contacted Union Pacific, I talked to Boise Cascade, I looked at a whole bunch of SEC filings of the largest supply chain operators in the US and internationally, and either they wouldn't publish it in their SEC filings, and then also, I was not the only one that was running into problems with this, is that firms would not publish that data or release sample data to economic researchers. They would do the research themselves and the analysis themselves, and then release the information of what the results that were. And so that was a large problem for not just me, but other researchers, is that a lot of the sampling data was extremely biased. I mean, if a firm is, it's a firm's best interest to say that this is how the analysis is going and we are collaborating. However, there is large logical reasoning evidence, and there's a lot of research of understanding of the market by in their textbooks and other experts in the supply chain field that agree with this statement, is that they will condense down, and that the decision making starts with either we're going to signal or not to signal to further collaboration, and that the game change, and then after a series of years, from my research, I found that it's about 5 years, is that they will either commit to collaboration, or if they don't, before 5 years, if they don't commit to collaboration, they will cut off the relationship. And there's not any empirical evidence that I could say that statistically this is why, is more talking to people in the, in that market.
So what's the incentive not to collaborate?
The incentive is that there's this idea of a holdup problem, and if I release asymmetrical information to my supplier, then he will have, when we come to renegotiate our contract, he'll be in a better position to negotiate.
Gotcha.
And so the pros and cons and the way off the firms have to create is that how much information I release and what's the cost for releasing that information. And I found that the inventory, that the easiest information that they release is the inventory information, especially because there's a practice in supply chain where it's called supply side inventory management, where all my inventory information is 100% available to my supplier, and then they just daily and make those decisions like, okay, my log count is down, and so they fulfill that order automatically, and I don't even have to worry about my inventory management anymore. It's just completely handled by my supplier. And that is a reflection of the marriage I was talking about beforehand, and that if that's like the ultimate goal is an inventory side, supply side inventory management, is that if you have that, it is one of the most effective inventory management systems out there, and that they will have over a 99% success. There's instances of 99% success rate. So to kind of hurry up and conclude, in my study itself, I found I was looking at pricing and inventory variation, and the results of it is that I found that there was the p-value was like 0.0001 for both of them, and the r squared value is 0.97. And I did an F significance test, and it passed that, where I found the F value and compared it to the critical value of an F chart, and it fell under it. And then I also did a reset test, and it found that the data was linear, and so those were pretty significant findings. Like I said before, there's a lot of problems with this, this research, the lack of data, the biased data, there's changes in technology. About 40 or 50 years ago, when the globalization was just starting to happen, there was a lot of research done, and there's still continuing research today, but the best research I found was from the 60s, 70s, and early 80s. There was other studies back with similar game structures that I had that were actually very similar. They had mathematical proofs. I do not have the mathematical background to do the same proofs that they did. I just kind of assumed that, okay, their game model is very similar to mine, so my game model has practical application. And the conclusion that I could draw from my study is that decreasing marginal costs and decreasing inventory variation are two very strong signals for firms looking to collaborate with each other. It does not prove collaboration. As I said, this